Now I have the pleasure to introduce Robert Dryfe. Robert Dryfe is professor of physical chemics, and also director of Molymem. And today he will share a novel patented membranes for enhanced filtration systems. Robert, over to you. Enjoy.
Thank you for the introduction, Christoph. I hope everybody can hear me okay, and you can see my slides without any problem. And so this is the introduction to our company Molymem, as Christoph has said. We are a spin-out company from the University of Manchester, and we are developing a membrane system based on what might be a new material to some of you, based on molybdenum disulfide. But this is actually a commodity material, so it's clears, we think, a lot of regulatory barriers that might be associated with the use of a completely new material in some of the markets that we're envisaging. So just to give a little bit of background, because I guess there's people here from a lot of different areas in this talk, so apologies if you're very familiar with the membrane and separation area, but membranes are clearly used across multiple industries for filtration and separation of liquids and gases. And they're widely used. Membranes suffer from various problems. Basically, membranes are often used in harsh environments, and that leads to the fouling of the membranes and their degradation. And that means that we have to do repeated cleaning cycles to recover these membranes to their original performance. And as well as harsh chemical environments, membranes are often used under relatively high temperatures, which again can contribute to the degradation. So as well as the costs associated with this, the purely financial cost, we should also think about the environmental costs. So the point about membranes is to be a clean technology and to clean up, for example, wastewater to improve the environment. But if you look at the pictures on the right, here we have typical commercial membrane cartridges, and here we have images of skips, which are full of these disposed membrane cartridges. So there is a question about the sustainability of membranes. We want these devices to last for as long as possible. So new materials for membranes are needed to improve sustainability and to open up new markets. So this is where we come from with the Molymem concept. So if I move to the next slide, then the opportunity here is, well, there are several opportunities, as we'll explain in the next part of the presentation, but one particular one that we'd like to focus on is the water treatment subsector. Now, in most developed economies, there's increasing concern about the level of pollutants in water. We're extracting in the West more and more water from groundwater supplies, and there's more and more stringent legislation about the levels of compounds such as nitrates that are in those supplies. And of course, as we're living in increasingly industrial societies, there's more and more scope for pollutants derived from man-made activity to permeate into the groundwater. And to give a specific example of that, it's well known that in some cities, water is recycled essentially, and that means that often pharmaceutical residues, which have either been flushed directly down the toilet or excreted in some other way, can end up in groundwater supplies, and therefore they need to be recovered from environmental reasons, and also if that water is to be reused for human consumption. So to be specific, these drug residues in the environment, as well as potentially causing a problem for us, they can lead to adverse effects in the aquatic world. There's concerns about the effect of drug residues on the reproduction of various fish and so on. So basically, we need new methods of removing these types of organic compounds, drug-related compounds, for example, from wastewater supplies. And that basically means that we need new advanced filtration methods. And as I've said already, one problem, though, if membranes are going to be used for recovery of materials from water, one problem is the fouling of such membranes, which decreases their lifespan, as we've already talked about, as well as increasing costs. The second problem is that we need ways to clean such membranes, and many of the membranes that are currently used are not readily compatible with the harsh cleaning methods that one would like to impose, so therefore that restricts their lifetime. There's obviously an energy cost associated with especially thermal methods to regenerate membranes, and from the purely scientific point of view, we want to increase the selectivity of membranes. We want to remove more and more molecules, solutes that are in the waste water from using our membrane technology. So just to give a little bit of an overview of membrane technology today.